Okay, I'm going to go quickly through what we covered last class, okay? And then we will move on to new material, okay? So this is the rate of change of tangents to curves. We spoke last time about the basics here. You can see over here what we have is something that we did last time, so I'm not going to stay too much here. Delta y divided by delta x is equal to f of x2 minus f of x1 divided by x2 minus x1. Okay? And of course, f of x plus h minus f of x1 divided by h. Why? Because the difference between x2 and x1 is h. If the difference, which is delta x, if it is equal to h, then instead of f of x2, we can write what? F of x1 plus h. Because the difference between x2 and x1 is h, right? Minus f of x1 divided by h. Anytime you divide by something, make sure that that thing is not equal to 0. Okay? So the average rate of change of y, which is also used as f of x, with respect to x over the interval x1 and x2 is given by this. So we're talking about the average rate of change. What is equivalent to the average rate of change? The same equation for the average rate of change, you used it for what? The derivative, right? The same equation, you used it for the tangent, right? The same equation, you use it for rate of change of what? The secant, right? We went through it last class. Everybody? Okay, good. So let's get going then. Here is the secant, right? Everybody sees the secant. And here is x1. There is x2, right? And f of x1 is right here. So this point is what? x1. F of x1, we call it p. Okay? This is x2. So if we move to the function f of x, this is f of x2. So this is x2, f of x2, and this point is q, right? And the curve in blue is y equal to f of x, right? So what we have over here, a secant to the graph y equal to f of x, okay? Which is, this is a secant, right? Its slope is delta y divided by delta x. The slope of this secant is delta y, which is the difference in y, divided by delta x, which is the difference in x, right? We went through this. Anybody not following, let me know. Otherwise, we'll continue. Okay? So now, this is basically the tangent of this angle, right? Delta y divided by delta x, or delta y divided by h, is the value of the tangent to this angle, right? And it's also the slope of the secant, right? It's also the slope of the secant, the slope of this line, okay? Now let's take a look at this. It says find the rate of change of the function f of x between the 2 points. So if we want the rate of change of the function, we have to do the derivative of the function, right? So the rate of change of this function, how are we going to do it? We'll do the derivative. So the function f of x equals to what? Equal to x squared minus 4x, right? Yes. So derivative of f of x, f prime of x, right? F prime of x will be equal to what? 2x minus 4, right? And since we have to evaluate it between these 2 points, so we'll evaluate the first point first and then the second point first, right? So we'll say this evaluated between 2 and 4, right? Will be equal to what? 2 times 4 minus 4, and then let me put times, minus minus what? 2 times 2 minus 2 times 2 minus 4. Okay, 2 times 2 minus 4, good. 2 times 2 minus 4. So that's going to give us what? 8 minus 4 minus 0, right? Which is equal to 4, right? Everybody?
Yes.
Okay, good. Now, the second problem, an object travels in a straight line according to this equation. We went through that, right? We beat it to death yesterday. Basically, that means this is the distance taken, so if you do the derivative of the distance, you get what? The average velocity, right? Which is what we want. So we'll just do the derivative of the, this is the distance, okay? And t is the time. So derivative of the function, okay, will give us what? 6t minus 2, right? And we have to evaluate this one between what? 0 and 8, right? To evaluate between 0 and 8 is going to give us what? 48, right? Minus 2, right? And this is minus what? Minus 2, right? So 48 minus 2 minus minus 2 is plus 2, so it's going to give us what? 48, right? Okay? Clear? Okay. Now here is the secant and the move of the secant. Now we want to relate the rate of change of the slope of the secant to the tangent of the angle, right? And the derivative also. So consider this point Q and this point P, and we could go either way, from left to right or from right to left. Consider this Q and consider this Q is moving. So Q moved from this point to this point. So let's say this is the second point for Q, right? The secant has changed, right? The secant was this one. Now the secant is what? Is this one, right? New secant is this one, right? The slope of the secant has changed, right? Anytime you move it up, its slope will change, right? Now, let's suppose that Q moved from this point to this point, right? The secant has changed, right? And then let's say we move it to this point. The secant has changed, right? Each one of these blue secants crosses the function in 2 points, right? Because Q is moving around this line. Q came to this point, and then to this point, and then to this point. When Q came to P, what happened? How many places where the function crosses? 0. It doesn't cross. It just touches from the outside. Touches it and goes, right? That's called the tangent, right? Now, think of Q and P just like x2 and x1. So if this is an x1, think of this as x2. When we talked about x1 and x2, we said the difference between them is h, right? So assume the difference between them is h. So if I take the limit as q move to p, limit as q move to p, okay? What will be the value of the secant when we move to p? 0, right?
Yeah.
Because h is 0. Everybody? So it's right there, okay? So the tangent to the curve at P is the line through P, okay? So it's going to go through this point P, the tangent. The tangent is in red, okay? Whose slope is the limit of the secant slope. See, the slope keeps changing of the secant. As you move that way, keeps changing. Because the slope is the opposite divided by the adjacent, right? So it keeps changing. At which rate? The rate of that is the same as what? The tangent. Okay? So the rate of that is the same as the tangent. The tangent to the curve at the point P is same as what? is same as the limit of the secant slope as q moves to p. Okay, everybody got it? Yes.
I'm sorry, this question might be a little bit too late, but can you explain what the word secant means?
It's just a line that connects 2 points of a curve.
Oh, that's a secant?
That's it.
It has nothing to do with trigonometry?
Huh?
It has nothing to do with trigonometry?
I don't know if they're using it somewhere, but anyway, for the calculus is the base of everything. So calculus, the secant, is just a line that connects 2 points that were connected by a curve. Okay? So you can call it anything you want, but the end is that what we want is we want to take the limit as q approaches p. At which rate? And that rate is the same as the tangent. That's a good question, by the way. But definitely, without calculus, none of the other subjects would have been existing, would have made any sense. This is the key for everything. Okay. Is there any need for me to explain this? The move from the left is the same, right? It's the same. As q keeps moving, what will happen? What will happen to the secant? As q keeps moving, what will happen to the secant? Gets smaller, 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 and what will happen to the angle? Yeah, the angle over here, as you move this way, the angles are increasing, right? Right? The angle of the secant increasing, right? If you're moving this way. If you're moving this way, the angle of the secant is what? Decreasing, right? Okay. Now let's take a look at this. Find the slope of the parabola y equal to x squared at the point 2 and 4. Okay, so the parabola, let's suppose that this is the x-axis. Okay, let's say the parabola is something like this. So at 1 it's equal to 1, at 2 it's equal to 4, right? And at 3 it might be equal to 9, right?
Yeah.
Sorry, I squeezed them in a small area. Okay, and likewise it's an image, right? Because this is an even function, right? Even function is symmetric about the y-axis, right? Okay, so we want what? We want the slope at this point. So this is our point P. Okay, its x value is what? 2. Its y value is 2 squared, which is 4. Very good. Okay, so if we want to find the tangent at this point, all we have to do is we have to get the derivative of the function, right? Derivative of the function. So f of x is equal to x squared. So f prime of x, or derivative of f of x, is equal to 2x. And since it is 2x, we want to evaluate it between what? Between 2 and 4, right? To evaluate it between 2 and 4 is going to give us what? 8 minus 4, which is equal to 4, right? Everybody? Now, this is not the end of the question. Last class, I did not continue with it. They want what? They want the equation of the tangent. Okay? So we want the equation of the tangent. Is the tangent straight line?
Yes.
That means the linear function. So every linear function, f of x, equal to what? mx plus b. Right? Okay. So let's go ahead and figure out f prime of x will give us what? The slope.
Yes.
The slope is the tangent, right? So the slope, we got it equal to 4. So this is equal to 4x plus what? B. Right? 4x plus b. They gave us the point x equal to, y equal to 4, right? So this is f of x. So I'm going to say f of 2 is equal to how much? F of 2 is equal to how much? 4. 4 from this. Because f of x equal to x squared. So f of 2 is equal to 4, right? And 4 is equal to how much? 4 times x. 4 times x. What about 8? Plus b, right? Everybody? This implies what? B is equal to what? Minus 4. Huh? B is equal to minus 4. Do the math.
Okay, technically it works, but I don't feel like it makes sense.
Huh?
It works technically if you do the math, but I don't feel like it makes sense.
It doesn't make sense to you?
Yeah.
Okay. What's the general statement for a linear function? It's mx plus b. Every linear function, this is the general equation for the linear functions. Every linear function. Okay? Our linear function f of x, right?
Okay.
Our linear function f of x. Right? Or if you don't want f of x, let's call it g of x. It doesn't matter. It doesn't matter what we call it. We're looking for.
Okay. If b is the y-intercept, correct?
Yes, b is the y-intercept. Very good.
Then that implies that when the parabola is at y equals 0, then x equals -12.
No. We're not looking at the parabola. We have something like this, a curve like this, and we have the point P. We have the tangent. We want to.
This is the y-intercept.
Yeah, we're talking about the tangent. That's what I said. We're talking about the tangent. We want to get the equation of the tangent. See here? Write the equation for the tangent. I read it. Okay? So the tangent is a straight line, so call it g of x tangent. Okay? mx plus b. And then from there you could go. Okay? Everybody's comfortable? Some people are too tired maybe. They've been all night long up studying for exams or what? Wake up please. Okay, so everybody knows that b is equal to what? -4. So the equation of the tangent g of x, so let's say tangent, okay, we call it g of x, its equation is equal to what? M, what is the value of m? 4, x minus 4. Okay? Everybody? Good. Let's go to the next. Here is a problem that we went through yesterday, and we spoke about this. Everybody follows this by doing the analysis. You end up getting this, right? Is everybody comfortable with this equality? Huh? Okay.
We didn't use this all in the previous question.
Okay.
So are there specific cases where
Okay. Okay, let's go ahead and work out the equation for the slope of the secant. Okay? The slope of the secant. Where is the secant? This blue line. No, I think it's black line. Black line going inside and getting outside here. Okay? So its equation is going to be what? Its slope is the tangent, right? The tangent is delta y divided by what? The tangent, delta y divided by delta x, right? So let's put the slope of the secant equal to delta y divided by delta x, right? Let's take a look at delta y. Delta y means change in y. Okay? So if this point is 2, and this point is 2 plus h, that means the distance between them is h, right?
Yes.
Distance between them is h, right?
Yes.
Now, if we look at 2 plus h, this will be what? Because y equal to x squared, right? So find y at x equals to 2 plus h. Find y at x equals 2 plus h. It's going to be equal to what? If x is 2 plus h, what is the value of y?
2 plus h squared.
2 plus h squared, right? So this y is 2 plus h squared. And x is 2 plus h. Okay, so this is 2 plus h. Okay, and this is 2 plus h squared, because x is always over here and x squared on this side. Okay? Everybody's following? Okay, so this dotted line, what is the length of this dotted line? Delta y, which is equal to what? 2 plus h squared, which is all the way until what? This point. But if we want the tangent to this line, we don't go down, because we want just this. So we have to subtract this point. This point is what? This is y equal to 4. So 2 plus x squared minus 4, right? 2 plus x squared minus 4 will give us this length with a double arrow, this length. We're not going to take the whole length. Okay, we're just going to take the double arrow, which is delta y. So delta y will be the double arrow. So we can replace delta y by what? 2 plus h squared, okay, and then subtract from it 4, right? Everybody is following? Subtract from it 4, right? Why? Because we don't want to count this area. We just want the opposite, which is delta y, okay, divided by the adjacent, which is h, right? So this is divided by h, which is what we have over here, right? Now, how is it going to be equal to this? We could just execute this one. So this will be what? 2 times 2 plus 4h plus h squared minus 4 divided by h, right? 2 plus 2 is 4, right? 4 with this 4 is gone, right? And then I have h, I can take h outside, I will have what? 4 plus h divided by h, right? I can cancel h with h, I have what? 4 plus h, which is this one. Okay? Everybody? Okay, so I ask you this question. I said, how come the tangent slope is equal to 4? I asked you this question last time. Remember in the class I asked you? And one or two of you have answered it. Okay? But what we're going to do now is I'm just going to take your imagination a little bit. Okay? This is Q, right? This is the point Q, right?
Yes.
And this is the point P, right? If Q kept moving to P, what will happen to H? Until it becomes what?
0.
0, excellent. So can we say limit, okay, of the secant as P goes to Q, okay, as P goes to Q, that means P goes to 0, okay? So we want to find the limit of the secant at P goes to Q. And what's the difference between P and Q? Original distance.
Yes.
So I can say this is equal to limit as h goes to 0. Difference between them is h, right? P and Q, right? So as P goes to Q, h decreases, right?
Yes.
Until it becomes 0. So you can say limit as h goes to 0 of the equation, which is this equation of the secant slope. Limit as h goes to 0 of h plus 4. That's going to be equal to what? Yes?
Can we differentiate the the equations for the parabola and then plug in x, and that will give us the slope or the tangent that will fall.
Maybe you can, but what we're doing now, we're just following one way of doing it. Okay? Do you follow this way? Are you following? If you have any question about anything.
Right now, yeah, this is a new way for me. The way.
Okay, then no, let's keep us in this one, and then we can discuss me, and we can discuss it a different way. Okay? Everybody's comfortable so far. Okay? So the limit is going to be equal to what? 4, right? Which is the slope of the tangent, right? The tangent slope is equal to 4. The tangent is not the secant. They're different. The secant crosses inside and then coming outside, right? The tangent just touches one point. That's it. So they are related. Okay? Okay. The next thing, we have done it last time, and I think everybody should be comfortable with this one, right? We've done it. So we're saying limit as x moves to what? As x moves to 1, okay, either from the left or from the right. So let me put here, this is the x-axis, and let me put over here, this is the y-axis, and this is the point 1. Okay? Now, if I want to get the limit of this function as x goes to 1 by just plugging, let's put limit as x goes to 1 by plugging the value of x. So x squared minus 1 over x minus 1. If I plug in 1, I get what? 0 over 0. Undefined, right? UND, undefined, right? We can't do that, right? We said that last time. So we want to find the limit as x approaches 1. How does x approach 1? We look at point 9, and then from point 9 we look at point 9, right? And then put point 9, and keep going until you get what? Point 9. Okay, you go to infinity, but you cannot reach infinity, right? Can you reach 1?
Yes. No.
You cannot reach 1.
No, but here it reaches 1.
No, you cannot reach 1.
1 being 10.
You cannot reach 1.
But you can go over 1.
No, you cannot reach 1, period.
Okay, but here it shows 1.0001.
No, don't worry about 1.000. We're looking at just 0.9, 0.99, 0.999, 0.9999, and so on, right?
Because as we get closer.
I'm coming from the left. I'm stopping right here. I'm stopping at something very close to 1, but not 1. Okay? I could also come from the right. If I start from the right at 2.1, okay? At 2.1, then the next time I'll go 2.01.
So these are different directions.
Yeah, I'm coming from the left and I'm coming from the right. Okay? I'm coming from the left and I'm coming from the right. See, the book put them both together. I would have just put them like this. I would put them like this. This is starting from here. This is 0.9, okay? And this is 0.99. No, let me put the x-axis on this side. We're trying to approach 1. So 0.9, 0.999, 0.999, all the way until 0.9999 to infinity before this, right? Approaching from the left. And we can approach from the right? So we start from 2.1, we could go from 2.1 to 2.01, and then to 2.001, all the way until we get to what? To this. And in fact, if you do the math, you will find that 0.9 squared is equal to 1.9, right? 0.9 squared is equal to 1.9. What does that mean? That means when x is equal to 0.9, y is equal to what? Put 0.9 over here. 0.9 over here, that's going to give you what? 0.81, right? 0.81 minus 1. 0.81 minus 1. It's going to give us what? 0.81 minus 1 minus 19, right? Divided by 0.9 minus 1, 0.1. So divide by 0.1 and negative, so that's going to give us what? 1.9. Okay? So when x is equal to this, y is equal to this. When x is equal to this, y is equal to this. Okay? When x is equal to this, from the left, y is equal to this. When x is equal to this, from the left, y is equal to this. When x, okay? So this is approaching from the left, right? So when x approaches close to 1, y will approach close to what? 2, right? Yes?
Yes.
Okay. Now approach it from the right. If you want to approach it from the right, you're going to start from what? 1.1. Because 1 is right here. Okay? So you want to start from 1.1, right? So if x is equal to 1.1, 1.1 is somewhere in here, right? So 1.1 is going to give you what? 1.1 is given 2.1, right? This is the value of f of 1.1, right? And then if you go closer, you will be going to what? 1.01, right? 1.01. So 1.01 will put you at 2.01. 2.01 is smaller than 2.1, right? And you can see that if you go to 1.001, it will be 2.001. That means you're decreasing, eating up after the percentage. You want to leave just 2. Okay? And if you go that way, that means it will converge. As x moves from 2.1 all the way to, as x moves from 1.1 all the way until 1 point some, this is 1.1. As it moves until, let us say, I'm going to write it over here. 1, okay, 0.1, 2, 3, 4, 5, 6, 1. When x moves from this to this, then y moves from what? 2.1, moves from 2.1 to what? To 2.0001, right? That means in both cases, I'm moving from where? I'm moving the value of x closer to 1. But when they move closer to 1, the equivalent value of y moving closer to 2. That's what we mean. Is that clear?
Yes.
Everybody? Yes.
Can we take the limit of a function that does not have an undefined spot? Like, let's say, for example, when x is equal to 1, it's not undefined. Can we still take the limit, or the limit is just for when we have an undefined place or something like that?
Defined or undefined, the limit works.
So we can. So it's not just for when there is an undefined.
This is a case where x cannot be equal to 1. X cannot be equal to 1, right?
Yes.
But still we are able to get the limit. This is a common mistake, by the way. I mean, thanks for raising it. I realized from the previous years that students don't think that if you have a point that is not in the domain, they don't think that it has a limit. Yes, it does. It has a limit. Okay? So let's go ahead and get to the next one. Okay, here is the actual function, right? And here is what? After we did the analysis of the function and we cancelled out x minus 1 from numerator and denominator, right? This is x minus 1 into x plus 1, right? Right? X minus 1 into x plus 1. Okay, let me put the plus over here. Okay, divided by x minus 1, right? So x minus 1 goes to x minus 1, will give you x plus 1, which is this one, right? Yes?
Yes.
Everybody? What's the difference between this curve and this curve? I mean, it's not a curve. What's this line and this line?
The circle is closer.
Yes, the circle is closed. This is called what? The dot. It's the dark dot. And this is what? This is the open dot. This is closed dot. This is open dot. Closed dot means one is not in the domain. Because if you put one in the domain, that means what? You're violating the function. No function has as a result infinity, right? Because if you put one in the denominator, that's going to give you what? Going to give you infinity. So it's not allowed. If you want to compute the domain of any function, you always exclude what? What will give you infinity. And what will give you 0 if it is in the denominator, because that's going to give you what? Infinity also, right? Is everybody comfortable with this? So the limit, you can get it from this, you can get it from this now, right? How do you get the limit from this? It's simple. Limit, okay, for x plus 1 as x goes to 1 is equal to what? 1 plus 1, yes, which is 2, right? So you can get the limit regardless, whether the point is in the domain or not in the domain, okay? But if you just want to plug in the value 1 and this function, it's not going to work.
يعني افضل نحللها بعدين نعوض علشان يبقى لنا.
Yeah, there are a lot of techniques. It depends on the function itself. Yeah, but you're right what you said. Okay, question? Okay, let's take a look at some of the concepts. This function equals a constant. What does it mean to say the function equals a constant? It does not change, right? Let's say this is 2. This value is 2. Okay, this is, let's say, f of x. And the value is 2. Does it matter what is the value of x is? F of x will always be what? 2, right? F of x will always be 2. So, can I say limit of the function f of x, this one, as x goes to, let's say x not call it 5, as x goes to 5. What will the limit be? 2, right? It's not going to change. As x goes to 10, 2. As x goes to minus 1, 2. It doesn't matter, right? Because f of x is constant, yes. So regardless of the value of y. Okay? That means if you look at the domain and if you look at the range, in the range you have one value. In the domain, any value in the domain will map just to 1. Okay? So this is a function that's constant. One more time. If the range has just one element, then the function is constant. Constant value. Regardless of the value of y in the domain. Okay? The value, the range is not going to change. It's the same. Okay? So having said this, what's the relationship between this one and this one? X not equal to what? And this. X not and this equal to what? Compare this one and this one. X not equal to what? 1, right? And L equal to what? 2. That means a constant, right? Limit, if f of x equal to 2, which is a constant, it doesn't matter. X goes to what? It's the same. Okay? Let's take a look at this function. This function limit as x goes to 1 of x squared minus 1 divided by x minus 1 is equal to 2. We just proved it, right? We just proved it equal to 2 by approaching from the left and approaching from the right, right? So you can prove using a table, you can tabulate, okay? You can prove also using a couple of methods. Like for example, you do the analysis, okay? Analytical. You could also by using the conjugate, which we will look at in a few minutes. Okay? You can prove it in different ways. Okay, now I want you to tell me graph A it has f of x equal to x squared minus 1 divided by x minus 1. This is the original function, okay? So this is our original function, and this is the function that we deduced from it, right? And we talked about the difference, that we have what? We have f of 1 as part of the function. Over here, 1 is not part of the domain, so f of 1 is not defined, okay? F of 1 is not defined, right? Regardless, the limit of this and the limit of this, both of them have a limit equal to 2, right?
Yes.
We just proved it, correct? Now this is a third function. This function, we wanted to patch. You know what patch means? We wanted to include 1 in the domain, so we add to this one, we add to this one what? A value for 1. We say when the function is equal to 1, let's put it equal to f of x equal to 1, right? So now the three functions, okay, how are we going to represent this function? Now it has two parts, and this is called piecewise function. The first part is allowed for x not equal to 1. When x equal to 1, the value of f of x equal to 1, okay? So this is a piecewise function. You're going to be dealing with piecewise function quite a bit, okay? Is everybody comfortable? So all three functions, f of 1 is equal to what? Limit as x goes to 1 is equal to 2, right? For all three. Yes, everybody?
Yes.
Good. Let's going then. Now, here is something that is not difficult also. What we have here is f of x equal to x. This is called the identity function. F of 1 equal to 1, f of 10 equal to 10, f of c equal to c, f of negative 5 equal to negative 5, f of infinity equal to infinity if there is one. Okay? So, for any value of x naught, f of x, okay, will be equal to what? X naught. For any value of x naught, right? F of x as x goes to x naught, that means we just replace x by x naught. F of x naught will give you x naught. That means limit of x as x goes to x naught is equal to x naught. Right? Is this similar to the one I just discussed?
Yes.
Good, good. Let's take a look at 2. 2 says what? Limit f of x as x goes to x naught equal to limit k as x goes to x naught equal to k. So this one is what? A constant, right? Regardless of x goes to whatever. Because limit, we're looking at limit of a constant, not as a variable. This is a variable. This is a constant. Limit of a constant is a constant. Limit of 3, as x goes to million, it's still going to be 3. It's not going to change. Right? So this one is relating to which one? This one is related to which one? The second one. Everybody see that? Good. Good. Let's get going then. Okay. Here is the explanation. This is the identity function, right? X naught will be equal to x naught, x1 will be equal to x1, x0 will be equal to x0, x5 will be equal to x5, x anything will be equal to that thing. Okay? And over here is what? The constant. F of x equal to k. That's it. Y equal to k. It's not going to change. X equal 1, 2, 3 million minus 5, pi by 2, whatever. No. It's the same. Okay? Now, let's take a look at this. Discuss the behavior of the following functions. Okay? The first function, it's described as u of x equal to 0 for x less than equal to what? Less than 0, right? So let's put the x-axis. Let's put the y-axis. Okay? If I put the x-axis, I'm given what? For x less than 0. This is the origin. The origin is what? 0, 0, right? The origin is 0, 0, correct? Now, I'm going to just scratch hash it. Okay. Until infinity. This is what? X less than 0, right? X less than 0. I'm going to put here an open dot. Why do you think I'm putting an open dot?
Because it doesn't exist.
Yes, because what? Yes, it's not defined, right? And over here, for x greater than or equal to 0, the value of y is equal to 1, right? So the value of y is equal to 1. So I put what? Closed dot, and this is the 1, right? So this is the open dot, right? And this is the closed dot. So this is the function. The cross-hashed one is the function. Everybody sees it? Huh? Okay. I'm going to do this one also, and the other one I'm going to leave it for later because it's a little bit complicated. We have to get in the material a little bit more, and then I can discuss it for you. Now I have 1 over x. Let's just go ahead and do this 1 over x. Okay, so 1 over x. If f of x is equal to 1 over x, f of x is equal to how much? 1 over x. For 1, f of x will be equal to what?
1.
For 2. شباب ليش بيطلعوا بيرجعوا هم شباب؟ ها؟ لا يا شباب اللي بيطلع لازم يحدثنا يعني انه نحن مطلوبين انه الطالب لو غاب 10 دقائق يكتب ايش؟ مش منه حاضر بس يكتب ايش؟ انه متاخر. ومتاخر it will trim on your attendance. ها؟ عشان بريك اطلبوا بريك نعطيه بس ما يعني الواحد لما تفوت المفروض لا هذا اتفاق اذا اتفقتوا انه مثلا تاخذوا الساعه ونص وتطلعوا لازم يكون في بريك؟
اذا بناخذ ساعه على حسب الطلاب يكون بريك.
لا عادي انا في هالجامعه يعني
في عند الدكاتره ما ياخذوا بريك بس مش اللي قبله في دكاتره ياخذون بريك.
لا اي نعم بس المقصود ايش؟ المقصود انه الطالب لما يجي طالع يخبر صح ولا لا؟
المفروض يخبر
بس
يعني يقول لك ممكن ثاني بريك.
لا عادي بدكم بريك الان ناخذ بريك ما مشكله.
اذا خلص بدري لا
اي هذا اللي انا قصدته يعني تخلصوا بدري وتمشوا احسن لكم من ما تاخذوا بريك يعني. ها؟ تفضل حياه اللي بده يروح على دورة مياه حياه عادي.
بس يستاذن.
بس اي نعم خبرونا عشان انا ماني عارف يعني. في واحد كان مسكين انا افتكرته مريض ولا شيء في الكلاس الماضي يمكن هيك. اي واحد افتكرته مريض يعني بس طلع انه ما انه مريض يعني. يعني okay so the function f of x is equal to what? Equal to 1 over x, right? So for 2 what will the value be? Half. For 3 what will the value be? 1 over 30. For 4 so you can see the function going like this, continue to decrease, but it will never touch the x-axis. It will never touch the x-axis. Okay? Now, this is f of 1, right? What about f of 1.1? F of 1.1. Okay, so we're going 1, 2, 3, 4. What if I went, instead of 1, I went 0.9? F of 0.9. Is it greater than f of 1 or less than f of 1? Greater than, very good. F of 0.9 greater than. Okay. What about f of 0.5? Greater than. And keeps growing up, but it will never touch the x-axis. The y-axis. It will never touch the y-axis. It will keep growing, but it will never touch it. Right? That means the function is this way. And if we look at its image is going to be this way also. Okay? So I don't want to cross hash it, but anyway, I'll just make it easier for you to look. This is the function. Okay? This is f of x equal to what? G of x equal to 1 over x, right? What about for x equal to 0?
0.
The value is 0. That means this point is what? Closed dot or open dot?
Close.
Closed dot. Very good. Because it's defined. Greater than or equal to 0. That means 0 is in the domain. Right? I'm sorry, x equal to 0. This one. X equal to 0. So 0 is in the domain. Okay? Okay, everybody? These are the functions. This is the first function, okay? And now it's called piecewise function. And this is the second function. This function is sine of 1 over x. It needs a little bit more explanation, and we need to get into maybe two chapters before we can really tell you exactly what it is, because if I tell you now, it's going to confuse you. Okay? For example, this is sine of any value. Forget about this small value. Sine of some value. Sine 0 equal to how much?
0.
Undefined. See, that's why we have this dotted lines as you approach 0, right? Follow the function this way. As you get closer to 0, the function will no longer have specific values. It has it. So we're not going to talk about it now. We'll talk about it later on when we get to that level. Okay? Erased? Ya Allah. I'll write it down, no problem. Okay, so this will be c cubed plus 4c square minus 3, and this will be c to the power 4 plus c square minus 1 divided by c square plus 5, and this is going to be equal to the square root of 4 multiplied by minus 2 square minus 3, and that's going to give us what? That's going to give us the square root of 16 minus 3, which is equal to square root of 13. Okay? You're welcome. Okay, Shabab. Let's take a look at this. This is a polynomial. Okay? See, this is p of x, the polynomial, and these are the terms of the polynomial, right? So limit of the polynomial is what? Is just like you plug in for every x, you replace it by what? By c. So the first term, a sub n x to the power n becomes a sub n c to the power n. Second term, a sub n minus 1 x to the power n minus 1, it becomes a sub n minus 1 c to the power n minus 1, and so on until a naught. Okay? Just plugging. Limit of a rational function. Okay? If p of x and q of x are polynomials, then q of c is not equal to 0, because all the time, anytime you have a denominator, you don't want the denominator to be equal to 0, right? That's why this condition is very important. So limit as x goes to c of p of x divided by q of x is equal to p of c divided by q of c, given that q of x is not equal to 0. This is important. Yes? Yeah, go ahead, please. Okay? Now, let's take a look. The following calculation illustrates Theorem 2 and 3. Let's take a look at limit as x goes to -1. Can we just plug in -1? Yes. Why? Because the denominator, if you put -1 in the denominator, it's not going to give you 0, right? So we can get going. So -1 will give me -1 plus 4 times 1 minus 3 divided by what? 1 plus 5, which is 6, right? And that's going to give me what? Give me -1 plus 4
0 over 6.
minus, yes, 0 over 6. Excellent. And that's going to give us 0. Okay? Now, we want to evaluate this as x goes to 1. Will the denominator go equal to 1?
No, it makes 0.
It's going to be 0, right? So we have to do what? We have to do x minus x plus 2, x minus 1, right? Just go ahead and factor this. X plus 2, x minus 1 divided by what? x outside and then x minus 1, right? So x minus 1 kills x minus 1, right? We have x plus 2 divided by x, right? So now we can plug in 1. So if we plug in 1, it's going to give us what? 1 plus 1 divided by 1. No, it's going to give us 2.
1 plus 2.
1 plus 2, sorry. 1 plus 2 divided by 2
3.
divided by 1, so that's 3, okay? Okay, everybody? Okay, that's good. Now, here is the function, the original function, right? Here is the function for which we took care of the value of f of 1, right? This is similar to the straight line. Remember the straight line? Everything is similar, so I'm not going to go ahead and go through it, because anytime you do the analysis, the analytical way of removing the zero, right? The zero is just like the roots. You studied in your calculus before, the root of a function, right? The root of the function is nothing but what we're talking about now. These are roots, okay? Now, this is just description to what we have done, so we could just go ahead and read it later on. Okay, here is evaluation, another evaluation. We want to evaluate the limit as x goes to 0. Can we evaluate it?
No.
Because the denominator will be equal to 0, right? So what we will be doing is we will be taking this square x square plus 100, right, minus 10 divided by x square. We have to multiply it by square root of x square plus 100 plus 10, okay, divided by square root of x square plus 100 plus 10, right? The top will give me what? Will give me x square plus 100, okay, with or without minus 100, right? Right? The bottom is going to give me what? X square, square root of x square plus 100 plus 10, right? Now, this goes with this, right?
Yes.
X square goes with x square, right? So I'll have 1 divided by, we want the limit as x goes to 0. Limit as x goes to 0. So the limit as x goes to 0 of this, let's put limit as x goes to 0. We have 1, and then in the bottom we'll have what? We'll have 0 plus 100, right? 0 plus 100, right? Plus 10. That's equal to 1 over
20.
square root of 100 is 10, plus 10 is 20. 1 over 20, right? Everybody? Everybody's following? Good. Good. Sandwich theorem. Sandwich theorem is interesting theorem. Okay? Take a look at h of x. Look at the values of h of x. The values of h of x are in, is it purple? Purple color? Okay. Is there any value for g of x that's greater than h of x?
No.
So every value of h of x is greater than the value of g of x, right?
Yes.
Every value of h of x is greater than f of x, right? Every value of f of x is greater than g of x, right? The point C is not included in any of the domain of the other ones, right? Then, if we take the limit of g of x as x goes to C, if we take it as equal to L, and we took limit of h of x as x goes to C is also equal to L, that means it implies that the limit of the function f of x as x goes to C is also equal to L. Sandwich. Limit h of x as x goes to C. X can come to C from the left, can come to C from the right, right? But the limit will be L. Q can come to C from the right and come from the left, the limit will be L. That means also for f of x, if you keep going to go to C, when you end up at C, the limit will be equal to L. This is called what? Sandwich theorem. So if you have two functions sandwich, okay, two functions sandwich a third function in between at a point where that point is not in any of the domains, then the limit of the middle one is equal to the limit of the first, equal to the limit of second. In other way, if it is very hard to find the limit, use what? Sandwich theorem. And I'm going to conclude by showing you one problem. Okay? Let us see if we can look at. I'm going to have to do it in a more room. I will have more room over here. I'm going to do it over here. Okay? I'm going to do it over here, and then you can see that explanation is easy. Okay? Now, please pay close attention. It's very important. If you blinked or turn, you're going to lose me. Okay? So make sure that you focus. So I want to find, okay, I want to find limit as theta goes to 0 of sine theta over theta. Okay? So now I want what? Limit as theta goes to 0, sine theta over theta. Okay? Everybody is following? Okay. Now, yes?
Sine less than 1 and greater than minus 1. We can use this to evaluate the equation.
Yeah. Anytime we have, yeah, you're on the right track. Anytime you're given, find the limit, first of all, plug in and see if the denominator is going to create a problem. Will the denominator create a problem here?
Yes.
Because the denominator is going to be equal to 0, right?
Yes.
We know sine 0 is going to be equal to what? 0, right? But then the denominator is the problem, right? So we have to use the sandwich theorem. Okay? We can use the sandwich theorem in two ways. I'm going to give you the geometric way because you're good at geometry, right? You've taken courses in geometry in the high school, right? Geometry is the area of a circle, area of a rectangle, area of triangle, oh, that's geometry, right?
Yes.
Okay, so let's just use geometry. Okay, what I'm going to do is I'm going to draw a circle. I'm going to draw a circle, okay? Please. Say that the radius is equal to 1, okay? So this radius is equal to how much? 1, okay? I'm going to go ahead and draw and I'm going to draw this one over here. Okay? So this is a triangle inside. You see the triangle?
Yes.
I'm going to call this angle. I'm going to call this angle theta. Okay? I'm going to call the length of this inside sine theta. And the length of this cosine theta. Okay? Now, what is tan theta? Tan theta. Sine over cosine, right? So that's okay, right? Is everybody comfortable with that?
Yes.
Good. Now let me go ahead and add something else. Oops. I'm gonna draw a secant. Follow me, please. Oops. I have to draw a secant. The secant will be something like this. The secant is going to be something like this. Right? Straight line. Consider it straight line. Okay? That's a secant, right? Everybody sees it? Okay. Now, how many triangles we have? No, 3. Very good. 3 triangles. Right? 1/2, 1/2, and the whole thing. 3. Right? How many sectors do I have? 1 sector. Sector. This is a sector. Oops. This is a sector. Sector is like this. Okay? Now, I want you to look at what is the radius of this? We said 1, right?
Yes.
We said the radius 1. Okay. Now I'm going to compare the triangle inside the bigger one, not the baby ones, the bigger one. Give me the area of the bigger triangle. The area of the bigger triangle. Half of the base multiplied by the height, right? Half of the base multiplied by the height. Wake up, please. Okay, so how much is going to be? The bigger. Huh? Half of the base. The base is equal to 1. The bigger one. The base is equal to 1.
Yes.
It's the radius, right?
Yes.
So half of it is half. Multiplied by what? The height. What is the height? Sine. So it is sine theta over 2. That's the area of this big triangle. Correct? Huh? Okay. Now let's take a look at the radius. Okay? I'm going to put this. Okay? I'm going to put something like this. Okay? And I'm going to put an angle like this. This angle is how much? And this angle is how much? Theta. Right? I'm going to put something like this. What is this angle? Yes, pi. Very good. Okay? Now, I'm going to use the ratio. Okay? If I want the area, I want to use the ratio. What's the area of a circle, complete circle? Huh? Pi r squared. Okay, what's the area of half of it? Half pi r squared. Right? What's the area of 1/4 of it? Huh? 1/4 of pi r squared. Okay? Now, you see 1/2 is the flat line. And this is what? 1/4 is this angle. Okay? I'm going to say the area of this is going to be equal to the ratio over 2 pi multiplied by pi r squared. Think about it. Okay? The area of that sector is theta divided by 2 pi.
And 2 pi is the
2 pi is the circumference. Now, look at it over here. What is this angle? 90, right? That means this is what? Pi over what? No, this angle is 90. Right? It's pi over 4, right? So pi over 4, the ratio will be what? If I did pi over 4 divided by what? 2 pi, that's the ratio. And I'm going to do what? Multiplied by pi r squared to get me the area. Right? Okay. So if that is the case, then pi theta divided by 2 is the ratio. Multiplied by what? Pi r squared will give me this area. Okay? So now we can cancel pi with the pi, right? And we have r squared, r is equal to 1, right? So r squared is equal to 1, right? So I have theta over 2, right? So the area of this is theta over 2. But theta over 2 is the area of the sector is greater than this one, right? Yes? Yeah, the triangle is right inside the sector, right? Okay, I'm going to go ahead and draw another triangle. This right angle. Okay, I'm going to call this tan theta. Okay, I'm going to call this tan theta, the opposite, the same theta. Okay, what about the adjacent here? Adjacent is equal to what? The radius. Radius is equal to what? So tan theta divided by 1 is tan theta. Right? So that means if I have this tan theta, right? Tan theta divided by 1 is equal to tan theta. So I want to find what? The area of this big one, the giant triangle. Half the base is 1, right? Half the base times the height. Half the base is half, and the height is what? Tan theta. So it's tan theta divided by 2, right? Yes? Yes? Now I can get rid of the 2's, right? Right? All of them divided by 2, right? I'm going to divide by sine theta. Sine theta. Okay? Now, if I divide by sine theta, what do I get here? 1, right? And over here, I get what? Theta over sine theta, right? And over here, tan theta is equal to sine theta over cosine theta, right? So I can replace this by what? Sine theta, cosine theta, right? No, sine theta divided by cosine theta, right? Right? So you can see I can close this one with this one. I'm going to get what? 1 over cosine theta, right? Now I want to get the reciprocal. If I get the reciprocal, I will have 1 greater than sine theta over theta, and this is greater than what? Cosine theta.
If you get the reciprocal, do you flip the sign?
Yes. Let's see. 5 greater than 6 greater than 7, right? If I get the reciprocal, 1 over 5 will be less than 1 over 6 will be less than 1 over 7, right? But 5 is not greater than, 5 is less than, right? So this should be flipped like this, right? Okay. So everybody is following now? So we flip them. I want you to take the limit of the left and the limit of the cosine as x as theta goes to 0. What's the limit of the left as s theta goes to 0? Is 1, right? And what is the limit of cosine as theta goes to 0? Cosine 0 is equal to what? 1. So the limit is equal to 1, right? Didn't we sandwich sine theta over theta? Sine theta over theta. So limit sine theta over theta as theta goes to 0 is equal to what? Must be equal to 1, right? We sandwich it, right? So it's equal to 1. Is that clear? Everybody?
So limit of sine theta over theta as theta goes to 1 is 1.
Limit sine theta over theta as theta goes to 0 is 1, yes. Okay, just let's finish these two questions and then I'm going to stop for today.
Wait, I'm sorry. Can you undo it?
What?
Can you undo it because I want to take a picture?
Undo this? No, I can do it, but I cannot undo the erasing.
Okay.
But what was it? What did I have over here?
Limit sine theta or theta, I think. Yes, as theta goes to 0.
Okay, you can go ahead and. You're welcome. Okay, let's just go ahead and do the problems that we have, and that will be it for today. I know I push you a lot, but most of this is really review for you more than anything else. Okay, the first question. Take a look at it and let us see what are you supposed to do here. We have what? We have this function to the left and this function to the right. We want to use what? The sandwich theorem to find out what? The limit of the function u of x as x goes to 0. We don't know the function u of x, but we want its limit as x goes to 0. So we have to get what? The limit as x goes to 0 of the left and the limit as x goes to 0 of the right. Right? So what is the limit as x goes to 0 on the left? 1. Less than or equal to limit as x goes to 0 of u of x. And this less than or equal to, okay? This is also 1, right? So that means limit of u of x as x goes to 0 is equal to 1. Okay? That's the sandwich theorem. Okay? Let's get going on this one. We have 2 parts. Oh, we have 3 parts and then we will be done for the day. Sorry, it's a little bit slow, but it's better because it's gonna give us the lecture and the tape. So, okay, we want limit sine theta as theta goes to 0. Remember the one I told you, I showed you?
Yes.
Sine theta, it starts and then, okay? So, we're gonna leave this one for now, okay? What about limit cosine theta as theta goes to 0? It was just part of the one that we just finished, right?
1.
Equal to 1. Good. Okay. For any function f, limit the mod of the function as x goes to c equal to 0 implies that f of x as x goes to 0 equal to 0. Okay? Can you justify this, the last one? Yes.
The absolute value can be greater than
Right.
or less than.
Right.
Plus or minus.
Absolutely. That's it. And that's the sandwich theorem. Any question? Any question, Shabab? What is new that we went through today? Hey, sandwich theorem, yes. Anything else? The rest really is review, right? Okay, I think we will stop right here. We're going to have our first quiz on Wednesday. I'm going to send you something about, what you should do to get to the quiz, okay? And it's going to be on face-to-face. The quiz is going to be face-to-face. All the exams are going to be face-to-face. Okay? The quiz is going to be on chapter 1 only. Don't worry about chapter 2. Just chapter 1 only, okay? Any question? Barak?
It's not about this class exactly, but it's mentioned that the classroom for this session is 2502. So are we always going to be in this classroom? Or in this lecture room?
I went to 2502, but it occupied.
Yeah, there was a class, yeah.
Occupied, and I asked the person in charge, and he said if 2112 is available, take it. And one of the students came and told me that they came over here, so I came. So for this day we're going to be over here, but for Wednesday I don't know. For Wednesday, is it written in the schedule? Wednesday is going to be on 2114 2501. That means we will go there on Wednesday.
Then what's about this class? Maybe.
Huh?
So that should be our class. There, not the other class. There's another class there. What's going on?
Yeah, whatever they wrote that we have to go to, we have to go to.
And if that's occupied, we come here?
If it is occupied, I mean, it's not supposed to be, but if it's occupied, we have to look at the solution. If this is not occupied, if this is available, yes. I like this one better than that one. And a bigger room, and you can have a spread, and the systems are better. You see that board, very nice. This is a little bit ugly. So, let's see, inshallah. Okay, please take this course seriously. I don't want anybody to flunk. I wish everybody gets an A. I really wish, from the bottom of my heart. But you have to help me so that I help you to get an A. Okay? يلا بارك الله فيكم شباب. الله يكرمك. معليش واحد طويل منكم سلطة في هذه الله يرضى عليه. ها؟ شابتر 1 خلصنا. هو شابتر 1 اصلا ما المفروض نمشي فيه، بس نحن مشينا فيه حتى نراجع يعني. لكن اذا كان في اي سكشن ولا كذا تحتاج مراجعه اجيبه ونراجع ان شاء الله.
وكان ويك 1 بس ولا ويك 1 و 2؟
لا 1 و 2 هي شابتر 1 1 و 2 هي كله 1 و 2. نعم ان شاء الله.
يعني اشوف فيديوز اللي في الهوم ورك.
في فيديوز عن شابتر 1
نفسهم في الهوم ورك.
قصدك يعني بالنسبه للامتحان؟ انا حارسلكم ستدي جايد. The study guide will tell you exactly what to study.
اليوم ولا؟
إيه حرسله ان شاء الله باذن الله.
على فكره
يا جماعه ان شاء الله.
الكوز كم سؤال؟
والله ما ادري لحد الان، لانه عدد الكويزات حطيناهم 10. فاذا حطينا 10 كويزات ولا هذاك الهوم ورك ما ادري والله، لازم اشوفهم. الكويزات يمكن 3. الكويزات اذا كان 3 معنا يعني اتوقع يعني من 5 ل 10 مثلا ان شاء الله.